body. If a factor is now producing disease in the human body, that factor becomes a determinant of health. It causes the disease. It can be various physical factors, biological factors, genetic factors, psychological factors, social, economical factors, environmental factors, nutritional factors, lifestyle factors, behavior patterns. All these can be determinant of disease at any one point in time for a human being. Dynamics of a disease are actually the disease frequency. What is the frequency of the disease, occurring of the disease in different places? Disability, mortality, all these measure the frequency of the disease. Disability rates measure the frequency of disability caused by a disease in the population. Mortality rates, they measure the mortality caused in the population due to a particular disease. So all these, they measure the frequency of the disease in different ways. Disease frequency itself is measured by three tools: rate, ratio, and prevalence. The third D is distribution of disease. This all is in context to disease. So distribution of disease is in context, it is studied with regard to time of the disease, place where it is occurring, and person, what type of persons are being affected by that disease. And the most important thing is, behind all these three Ds, the philosophy is that the basic tenet of epidemiology is that disease occurs in patterns in a given community at any point in time when we are studying any disease or any health problem. So this was the detail of the three Ds of epidemiology, or the definition of epidemiology in easy words. Now, if we have done this, so that means we are going to now have some main categories or main areas of epidemiology. We have got descriptive epidemiology, analytical epidemiology. In descriptive epidemiology, we are just describing all the factors, whatever we see in human population, the health problems, diseases, the factors that lead to those causation of the disease, human factors, environmental factors, all these are being described. Observations are being made, data is being collected, and all this is being described. In analytical epidemiology, we are trying to identify association and causation between two factors, between 3 or 4 factors in the human population. For example, CA lung is caused by smoking. Is there any association between CA lung and smoking? Is smoking a causative factor for CA lung? So this is how we do the analytical epidemiology. But again, for analytical epidemiology, the base is being built up by the descriptive epidemiology. And from there on, we move forward a step ahead and we try to find association and causation through 2 main studies which are done for this purpose. Then the third section is the experimental epidemiology, which is called as the gold standard randomized controlled trials. One major study, one major type of experimental study. There are many others, but I'll give you one name, that randomized controlled trial, which is the experimental epidemiology part. That is said to be the gold standard study. So, if descriptive epidemiology is the base of every further step ahead study, what do we do in descriptive epidemiology? How do we do it? The first step in this procedure is that you have to define the population which is to be studied. जिस population को आपने study करना है, उसको आपने पहले define करना है. meaning by you have to define what is the composition of that population, what is the total number of that population, what characteristics are common in the all the units, meaning by the elements which are there in that population. So you have to describe and define the whole of that target population which you are going to study in your research. Then the second step would be that you have to define the disease which you are going to investigate. How would you define the disease? You are going to make an operational definition of your disease by which you will identify the disease in the population, and you will measure it by that, within the context of that operational definition. This is very, very important, because if we go into the field without having the operational definition clear with us, it becomes difficult for us to actually pick the right eligible cases. And sometimes our data gets mixed up and is not the correct data that we actually need for the to answer our research question. So conceptualization and operationalization of the main variables that we are going to use in our study, and the disease or the health problem that we are going to investigate in our research work, they need complete conceptual and operational definitions in written for us to refer back to them. Then the third step would be that we have to describe the disease under study with respect to person, place, and time. After that, we have to do the measurement of disease. Measurement of disease is done either by cross-sectional study or by longitudinal studies. And whatever the results are there, after measuring, we can compare those results with some standard indices. And then we are at the end, which is formulation of an etiological hypothesis. Descriptive epidemiology generates hypotheses, and those hypotheses are then tested in order to either accept them or reject them. So this is descriptive, the procedure for descriptive epidemiology. Now, as I said, that disease is described in context of person, place, and time. Let's see what is this. Now, if we talk about time distribution of disease, then according to time distribution, we have got some different patterns of disease. Diseases are seen. There are short-term fluctuations, there are periodic fluctuations, and there are long-term secular trends. Short-term fluctuations, one very common example is epidemics. Epidemic can be common source epidemic, it can be propagated source epidemic, or it can be slow epidemic. Common source epidemic is the one where either single exposure can cause the epidemic. For example, very commonly food poisoning. हम गए, हमने खाना खाया कहीं बाहर सबने मिलके, and when we come back, the group of people, majority of them had food poisoning. That is single exposure common source epidemic. It can be multiple exposure. For example, people in a community drinking water from some tap where the water supply is contaminated, and they have the only source of drinking water from that tap, and they are continuously being exposed to that contaminated water. वो उसी tap से पानी ले रहे हैं बार बार. So this is continuous common source exposure. The common source exposure epidemic can be single exposure, or it can be due to multiple exposures. Propagated source epidemic is when it is between man-to-man transfer of disease, for example, polio, Hep A, or it can be between arthropod, from arthropod vector, or it can be from animal reservoir. Slow epidemics are chronic diseases. Now, non-communicable chronic diseases, which are very common these days. These are slow epidemic. Obesity is one slow epidemic. Hypertension is slow epidemic. Then periodic fluctuations in diseases like seasonal trends. Seasonal trends, for example, acute respiratory infection is, it happens more usually in the early winter. A measles epidemic happens more in the spring time. This is seasonal trend of the disease. Then cyclical trends of the disease. Cyclical trends of the disease, they were very commonly seen in pre-vaccination era when epidemic of measles used to occur every 2 to 3 years. Epidemic of rubella used to occur every 6 to 9 years. So these are the periodic fluctuations, trends of the disease. Then long-term secular trends, for example, coronary heart disease, which can expand over a period of 10 years, 15 years, or CA lungs. So this is the secular trend which spans over a decade's time. So this is the time distribution of disease. And this is very important to understand in epidemiology, because when we are studying disease patterns or we are studying other human factors, then we have to keep all these three main concepts in mind, and then we can make use of the data that we are collecting and we are analyzing. Then place distribution of disease. Place distribution of disease is can be divided into international variations. For example, there can be a variation in a disease in developing countries and among the developed countries. Cholera is present here in developing countries in our country, but it is not present in the developed countries. We have got typhoid here, but in developed countries, typhoid is rarely seen. So these are the international variations. National variations in one country, in one part, some disease variation is there, and in other parts of that same country, it might not be seen. For example, in our country, in hilly areas, goiter is very common, but in plain lands, goiter is less common. Then we have rural-urban variations. Like in our country, we have rural area, we have urban areas. Rabies is more common in rural areas because of the lifestyle, because of their occupational, it's an occupational hazard for them because they are farmers most of the time, they work in the fields, and rabies is very common there. Snake bite is common there. But finding these two things in urban areas, in the city of Lahore or in Pindi or Islamabad, it would be very rare. So this is rural-urban variation of the disease. Then local distribution. In one city, central part of the city and outskirts of the city, there can be variation of disease because different factors are playing their role in the center of the city and in the outskirts. Obviously, those factors would be more because of the social economical reasons, and they would be then causing some difference in the disease causation. So this was a place distribution of disease. Then the third was person distribution, studying the disease with the perspective of time, place, and person. Person distribution of disease would mean all the personal factors of any human being. They would play their role in different ways in causation of disease. Some are modifiable factors and some are non-modifiable factors in every human being. Age is non-modifiable, sex is non-modifiable, ethnicity is non-modifiable, genetic composition is non-modifiable. We can't modify it, and they might be determinants of disease in some persons. Some diseases are gender related. Some diseases are age related. Some diseases are due to genetic predispositions. So we cannot modify them. Then there are factors which are modifiable: marital status, occupation, social class, behavior, educational level, stress level, migration, lifestyle, behavior patterns, exercise level. All these are modifiable factors which we can change if we want to change. And all these factors in any human being, when combined together, they can be determinant of disease. So this would be the personal factors. All this descriptive epidemiology, it helps you to generate hypothesis, which is further tested. So descriptive epidemiology actually is the base for hypothesis generation, because hypothesis is based upon all the data and the observations that comes from your descriptive epidemiology. I hope I'm not too fast or not too complicated for the students to understand. Muneeb, any comment in the chat box?
We have one question. One of the students is asking what, according to the classification that you just mentioned, where does COVID fall in?
Where does COVID fall in as per what
What type of
classification?
epidemic?
What type of epidemic? आप बताइए मुझे कौन सी होगी ये? What
So
type
you're
of
all
epidemic it will
okay.
be
So you're all free to
propagated?
type in your answers in the chat.
Students, type your answer in the chat box. मैंने आपको बताया कि एपिडेमिक्स में कॉमन सोर्स एपिडेमिक, जिसमें हमारे पास सिंगल एक्सपोजर फॉर एग्जांपल फूड पॉइजनिंग, मल्टीपल एक्सपोजर फॉर एग्जांपल कंटेमिनेटेड वाटर फ्रॉम अ टैप, प्रोपगेटेड सोर्स एपिडेमिक मैन टू मैन, आर्थ्रोपोड वेक्टर, एनिमल रिजर्वॉयर, एंड स्लो एपिडेमिक जिसमें हमारे पास नॉन कम्युनिकेबल डिजीजेस आ जाती हैं, डायबिटीज, मेलाइटिस, हाइपरटेंशन, कोरोनरी हार्ट डिजीज. इस तरह कहाँ पे आएगी कोविड? आंसर देखते जाएं मुनीब और फिर मुझे बताएं.
Okay, ma'am. Miss Mariam is saying propagated. Sobia is saying propagated. Ujala has also answered as propagated, and Nasir is saying man to man.
गुड. इसका मतलब है कि आपको समझ आ गई कुछ. Yes, you are right. Propagated. It's not common source. It's not single exposure or multiple exposure. It's propagated because it is man to man going on. So this was descriptive epidemiology. It leads to generation of hypothesis. In the previous slides, I had said that we have got a section of descriptive epidemiology, we have analytical epidemiology, and then we have experimental epidemiology. I'll give you just a small recap of analytical epidemiology because this is what you are mostly going to do. Case control study or cross-sectional study. Cohort study is a bit different. So analytical epidemiology, actually, here what we are going to do is that we test the hypothesis that you have generated from your descriptive epidemiology. And you test the hypothesis or the research question through case control study or cohort study. Now, case control study is for rare diseases and it's a retrospective study, whereas cohort study is for rare exposure effects and it is prospective, or it can be historical cohort. Case control, it moves back from the disease to the exposure factors, whereas cohort, it moves from the exposure factor towards the effect. Case control is cost effective and time effective, whereas in cohort, both these things are very difficult, it's very costly, and it is It takes longer time. One major uh, disadvantage in case control study is that direct incidence cannot be measured. But this is a positive in cohort study that we can measure direct incidence in cohort study. Measure of association in case control is odds ratio, and in cohort study, it is relative risk. And we can also measure attributable risk and population attributable risk. AR is attributable risk and PAR is population attributable risk. Case control study, we can, when we go back retrospectively, we can identify many causative factors to one problem or one causative factor to one problem. But in case of cohort study, we can study multiple effects that are caused by some exposure, and by the end of the time period which we have given to see the effect, we might be seeing not just one effect, rather some multiple effects can be studied in that case. So analytical epidemiology is this way. I won't be going into the details of study designs, otherwise I would have loved to do it, but since it's not my area right now to cover, I just thought to give you an overview about these two study designs. So, what have we understood so far? I'll give you 1 minute. Just type in the chat box whatever point you have understood, just write it down. I just want to see that you have got some concept, whatever concept, clear, but it should be clear. Whatever you have understood, just write down in one or two sentences that very point that is very clear to you, write it in the chat box, and Munib can then narrate it to me. I'll give you 1 minute and I'll take 1 minute break.
Okay, ma'am. So you're all encouraged to please type in your answers.
मुनीर, आपने मुझे ये भी बताना है at the end of 1 minute, we have got 20 participants, 19 participants leaving you.
Yes, ma'am. Leaving me and leaving you, we have 18.
18. 18 participants. How many total number of comments are going to come up after 1 minute? ये भी मुझे आपने फिर बताना होगा.
Okay, ma'am. Sure.
Students, whatever you have understood till so far, just write it down in the one or two points. Anything, not in detail, but just one or two points. Whatever you understood, it is not going to be graded or numbered, so don't be afraid about it.
So we've received a few answers so far. One of the students is saying epidemiology is a study of public health and it helps us understand disease spread. Dr. Muhammad Ajmal is saying he understood the definition of epidemiology and its types and applications. Ms. Aisha Iqbal is saying how a disease spread in a large number of population within a time period. That is what she's understood. And she said you've talked about types and applications. Mr. Asif Ali Thebo says he understood epidemiology and case control study and cohort. Sobia says we understand types of epidemiology. Priya says epidemiology and its types and the three Ds of epidemiology. Another response is that types of epidemics they've understood. Mariam says she understood epidemiology concept and its types. Ujala said she understood epidemiology, its type, descriptive, and analytical status. Farha again says epidemiological types. Mr. Abdullah Malik says epidemiology, case control, and cohort study. That is what he's understood. And Mr. Jamali said he's understood the difference between cohort and case control. We've received a
Okay.
similar answer from Mr. Ajmal.
So we have 18 participants, and how many comments have come up?
Let me count. 15.
15. Okay, fine. I'm glad that you have understood the difference between cohort and case control, although I have given you a very sketchy idea of it, not in detail at all. I would have loved to do that in detail, but that was not my domain at the moment. But I'm happy that you have picked up the idea of it. So moving on. Uh, मुनीब ये मूव नहीं कर रहा आगे
मैम आप अपने कीबोर्ड से नेक्स्ट का की प्रेस करेंगे
कीबोर्ड से ही कर रही हूँ अभी तो चल रहा था सही
मैम एक दफ़ा आप अपनी स्क्रीन शेयर को स्टॉप करके दोबारा कर लें जी अब हो जाएगा अब हो जाएगा
इसको साइड शो पे कर दूँ ना
जी
हाँ so the points that the comments that you have given in the chat box they show me that you have picked up and many of the things till so far so points to remember till so far whatever we have done the points to remember are that descriptive epidemiology makes use of the routinely collected data through surveys and it generates hypotheses. For example, data upon eating habits in young adults is collected through a survey. Data upon eating habits in young adults 13 to 19 year of age through survey and the data helped to generate a hypothesis which states that young teenage adults with unhealthy eating habits are more prone to develop obesity. It's just an example. So this is how descriptive epidemiology moves. ये जो hypothesis है इसको ज़हन में रखिएगा अच्छा हम आगे इसको यूज करेंगे अभी So descriptive epidemiology की मैं आपको एक example देती हूँ. John Snow, who is called as father of modern public health, in early 18th and mid 18th, in the 19th century, cholera epidemic happened in London. And at that time, they thought that cholera is being caused by, at that time, many supernatural theories were working for the people. That disease is caused by bad air, miasma theory, disease is caused by some supernatural phenomena, it is caused by something which is out of this world, but nothing natural. So this is how they thought that cholera is being caused. John Snow, he started mapping the cases. He started mapping the cases, and when he mapped all the cases, he found that most of the cases, they were clustered in the area of Broad Street. He then went there and asked the people who were living, who were the cases, and many other people too. And the people living there, they said, they complained that the water they were drinking, it smelled very bad, and it wasn't a something. It was not a good water to what they were having. He then looked into the source of the water. At that time, the water was being supplied to the population of London through two main water companies. One of the company was taking water from River Thames from the upper end. The other company, second Vauxhall company, was taking water from the lower end of River Thames. And River Thames, even in those times and even nowadays, it's full of sewage and contamination. So the water company actually, who the water company which was supplying water to the Broad Street water pump was the company which was taking water from the lower end of River Thames. And since the whole sewage of the city was being dumped into the River Thames, that actually flowed into the water. And when it comes to the lower end of the water, obviously the whole of the contamination was concentrated over there. And the water company, Vauxhall Water Company, that was taking water from the lower end, was supplying that water to the Broad Street pump. That was the reason, though, that contamination of water, sewage contamination of water, was the reason of causing cholera in that population. Whereas other half of the London city was taking water from the other company, which was supplying water from the upper end of the Thames. So obviously, upper end of the Thames, the water was better than the lower end of the Thames. So what did he do? John Snow, he removed the handle of the Broad Street water pump. He removed the handle of the Broad Street water pump, and now people were compelled to take water from the other company, which was supplying water from the upper end of the River Thames. And what happened? Number of cholera cases started to go down. Incidence of cholera started to go down. And that water pump, it stands there today too, with all the inscription written down at the base of it. It stands there in present times. So John Snow, this is how he mapped, he observed, he mapped, he asked, he inquired, and then he compiled the data, related the things to each other, and found what was happening actually. And cholera was not being caused by miasma theory or bad air. It was actually being caused by the contamination of the water which was being supplied from the lower end of River Thames. This is descriptive epidemiology. Then another example, in 19th century, again there, childbirth fever was very common, and mortality rate was very high after delivery, almost as much as 25%. Again, many theories, supernatural theories were working, bad air, toxins, atmospheric toxins, and magnetic influences, things like that, that these things are supernatural things that are causing the disease, causing this childbed fever, and mortality is happening due to it. At that time, there were two clinics for obstetrical clinics for the care of the pregnant females. First clinic and the second clinic. The first clinic, it was being staffed by and worked by physicians and medical students. And the second clinic, it was being run by and managed by midwives. Now, the obstetrician who was actually interested into this, the first clinic, mortality rate due to childbed fever was higher as compared to the second clinic where midwives were working. When he started looking back into the detail, what is happening in the first clinic, which is not happening in the second clinic, and which is actually causing a higher mortality rate in the first clinic. After observing the whole routine, their working pattern, their management and their duty patterns, everything, he came to know that the physicians and the medical students in the first clinic, actually, they are in the first part of the day, they are doing autopsies. And from there, after doing autopsies, they come directly into this clinic and they then perform the deliveries. So, whereas in the second clinic where midwives were working, they were just working there in that particular clinic and doing the deliveries and not doing anything else. But the first clinic where physicians and medical students, where they used to do autopsies in the first part of the day, and then they come directly to the clinic to do their second task of deliveries. So he advised them to wash their hands thoroughly, brush their nails, and wash their hands thoroughly after doing autopsies, and then go and do the deliveries. So he applied the hand hygiene intervention in the first clinic, and soon after applying that, he observed that the number of maternal deaths due to childbed fever reduced. So this was the intervention he applied as per policy. And how did he come to develop this policy and apply it? Just by observing the whole working environment, relating the factors to each other, and describing the whole phenomena, and then coming to this result that this is what is actually happening, and that intervention actually worked there. So this is descriptive epidemiology. It was just by the way to give you an example how descriptive epidemiology not only helps in generating hypothesis, but it also helps us to formulate a policy. This was a policy matter here. He developed the policy of hand hygiene, thorough hand hygiene after doing autopsies, and then go to do the deliveries. And that reduced the maternal mortality in that first clinic. Now, since we collect data in various forms from population through descriptive epidemiology, we have to measure that data too. We have to do some measurement from it. And the tools of measurement in epidemiology, the basic tools are rate, ratio, and proportion. These are the three basic tools. For any rate to be called as rate, there are three major criteria that should be fulfilled as to have it called as rate. I'll give that to you in the next slide. Now, in human population, in any population, morbidity and mortality, both these situations, they occur side by side. Morbidity is ill health, people having ill health, having influenza, having common cold, having anything which is causing ill health for some days. Morbidity then it affects the quality of life. It affects the productivity. So it is very important. And sometimes morbidity, it then jumps the border and goes towards mortality if the condition is such. So it is important to measure morbidity in any community or in any given population in order to do many things with it. Now, how do we measure morbidity? We measure morbidity by incidence rate, by measuring incidence rate. Incidence rate is number of new cases occurring in a defined population in a given time, divided by population at risk during that time, and your answer would be, or the rate would be per 1,000 population. Now, As I said, that to be called as rate, three criteria have to be met definitely, then it will be called as rate. One is that it has to be in a defined population. Second is it has to be in a given time, in a specified time. And third is that denominator has the capability, or or we can say the numerator. Numerator is number of new cases occurring in a defined population, number of new cases. The numerator has, it comes from the denominator. Numerator is coming from the denominator. It is being derived from the denominator because our denominator is population at risk. Population at risk means that the number of people here in the denominator can at any point in time develop the disease, and now they will be included in the numerator, in the number of new cases. They will be removed from here and they will come up in the numerator. So numerator comes from the denominator. This is very important in incidence rate. Any rate, defined population, given time, and that numerator comes from the denominator. This is incidence rate. Now, there are some other special types of incidence rates. For example, attack rate. Attack rate, we calculate it in food poisoning mostly. Secondary attack rate. Secondary attack rate is calculated in infectious or contagious diseases, where the primary case has occurred, and within the incubation period, the secondary case is also there. COVID is one example. Influenza is one example. One case of influenza in any house, and the other family members within 2, 3, 4 days, within the incubation period, they are infected too. Hospital admission rate, many other rates are there, which are calculated as incidence rate. But these are the 3, 4 main special incidence rates. Now, what is the purpose of calculating incidence rate? We use it basically for planning, prevention, and control of disease, which is our purpose in epidemiology. We use it for policy making, for research purposes, for planning purposes, planning and implementation of health policies, resource management, healthcare resource management. So it is used for many things in the healthcare sector. Then the second thing is prevalence rate, which is used to measure morbidity. Prevalence rate is number of all old and new cases in a given population at a given time, divided by total number of population for that time, and it is expressed as per 1,000 population. Total number of all old and new cases, that is going to give you the magnitude of the disease. Actually, the magnitude of the disease at that very time in the population. This is prevalence. Again, prevalence rate, it helps us in planning, resources, healthcare facilities, planning of the human resources. And the most important thing is that it can be used to make future projections upon a particular disease or particular health problem in the population. Now, prevalence can be of 2 types. Whenever we say prevalence, most of the time, rather not most of the time, every time we mean it's point prevalence. When prevalence is used simply as prevalence, take it's point prevalence. Point prevalence is at one point in time, one window cross-sectional picture of the population about any health problem. But if it is written, or if it is said, if we say that period prevalence, then this will mean that prevalence has been calculated during a specified period of time. Prevalence of COVID in Pakistan during between February 2020 till whatever time it goes on. I hope it finishes off very quickly. But suppose prevalence of COVID in Pakistan during the year 2020 and 21, prevalence of any other disease given between a long period of time over over any period, 1 year, 2 year, 5 year, that is period prevalence. We are covering the whole of that period and finding the prevalence during that period. So most of the time, prevalence is, when it is written just prevalence, that is point prevalence. So these are the two types of prevalence. Any comment from your side, students? Some comments of understanding from your side for this small section that we have done up till now. Anything you want to ask, or even if you, whatever you have understood, just give in a line in the chat box. After this, we are going to move on to basic biostats. Munib, I am within time.
Yes, ma'am. You still have 30 minutes left. 31
30
minutes.
Gee, students, any comment of understanding up till now? Further, the next small section that we have done. Munib, do we have any comment?
None yet, ma'am.
None yet. चलें ठीक है. पिछले वाले याद रखिएगा, आपने कहा था ना 15.
जी, ma'am. We have a few replies.
हाँ जी, क्या?
Okay, so Dr. Muhammad Ajmal says he understood prevalence, point, and period. Sobia said she understood everything well. Mr. Jamali Murtaza says incidence and prevalence rates. He understood them well.
Let's move on. I hope you are not tired.
And
Basic biostats. Munib थक गए?
नहीं ma'am, बिल्कुल नहीं. We're all ears.
अच्छा जी, basic biostats. Now, biostat is one section which is scary for everyone when we are doing research, probably. And it is something which needs to be done repeatedly. Even I myself tend to forget things if I don't revise them and I don't go through with them after some regular intervals. It's very volatile. We tend to forget it. So don't be scared of biostats. And mostly, since students are sitting here, I would say that I always advise my own students in college that at least pick up the basic concepts of biostats, because you have to do, you are taking this course to in order to learn about research methodology. And research cannot be done without biostatistics. And a good research would be where you yourself know the biostats and you yourself are doing the analysis and interpreting your results, because then you will be making more meaningful results. You will be developing more meaningful results and you will be learning yourself. So biostats is important in research. And it's all about data. Nothing but data, data, and data. It's all about data. And how do we play with data? What do we do with data? We collect data, organize data, present our data, analyze our data, interpret it, and disseminate it. So the cycle is collection of data, organizing it, presenting it, analyzing it, doing the interpretation of the results, and disseminating it to all concerned. ये नहीं कि हमने रिजल्ट्स कोई निकाले और इंटरप्रेट किया और उसके बाद उस किताब को बंद करके हमने रख दिया उन रिजल्ट्स को, फिर तो कोई फायदा ना हुआ. अगर हमने रिसर्च की और हमने किसी अच्छे एस्पेक्ट्स पे कोई रिसर्च की, तो उसके रिजल्ट्स को हमें कंसर्न बॉडीज को डिसेमिनेट करना होता है ताकि वो यूटिलाइज हों. What's the fun in doing research if it is closed down and it doesn't go out, it's not being read by others and it's not being referred to by others. So dissemination of the results is very important. Now let's see all these steps one by one. Collection of data. How do we collect data? There are many ways to collect data. Basic is observation. Observe, keenly observe around yourself, and you'll have rich data if you are an observant person. Surveys. We plan surveys to collect data. Specific surveys are planned, and sometimes surveyors are used if it is a big survey. Otherwise, at our level, at student level, or even at my level, if I'm doing my research, I tend to collect data myself. Then the other important and main factor is interviews. We do interviews. I have just forgotten to write one more thing here. Focus group discussions. Interviews and focus group discussions are another way of collecting data. Records. Hard records. Countries where records are maintained meticulously, they are a source, secondary source of data collection. For example, invest, health records, they are all interlinked. In USA, health records are interlinked. Once you are enrolled in the health record for some all the regular checkup, your record is it is there for the next person to make use of it, healthcare professional, and you don't have to carry the whole thing with yourself. If your consultant is changed, even then the health record is there, and that can be shared, that is accessible to the next person for you to get expert opinion. So records are one way of getting data. Then journals, diaries, logbooks, artifacts, these all are ways to collect data. Data is available from them if provided they are authentic, complete, and meticulously kept. Then narrative recounts. Narrative recounts from the persons um, who are eligible to do that narrative recount for your research. Narrative recounts also give you the data. So data collection is done by all these means. Then organizing the data. Once we have collected the data, we then have to organize the data. One more thing. Data collection, when we are when we are applying these ways to collect data, obviously there are tools which are to be applied within these means. Tools are different instruments that we use in our data collection. Instruments in the form of questionnaire, in the form of interviews, interview questionnaire in the form of close-ended or open-ended questionnaires, or focus group discussions. Again, there the guideline of questions is there. So the instrument are there which are implemented in these tools to collect data. Now, once data is there with you, suppose 300, a sample of 300, and you have got data from 300 study sample or anything, any number. You have to organize that data. You have various variables in your data, various factors. Some are socio-demographic factors and some are specific factors related to your research questions or your hypothesis. You have to develop code. You have to enter your data on the SPSS spreadsheet according to the coding that you have developed for your variables. You have to do the data cleaning of that spreadsheet. For example, meaning by that you have to see if there are any missing values, if there is any wrong coding done, or any wrong typo mistake is being done. So you have to either disqualify if missing value is there, or if there is any wrong coding, you have to correct it. Then you have to identify the scale in the SPSS spreadsheet. You have to specify your variable according to the right scale. Then you have to identify the numeric and the categorical data. Numeric data is the continuous data, but the categorical data is categorical. The code given to the categorical data does not mean that it now becomes numeric. At the back, it's still the categorical data. You have given it a code of 1, 2, or 3 just for identification. And then you have to either arrange it in ascending or descending order in order to have a complete one pattern of the whole data sheet. So this is how you do the organizing of data. Then we come to the third step, data presentation. Data is presented either in graphical presentation, or it can be presented by numeric description. Graphical presentation can be in the form of frequency distribution charts, histograms, box and whisker plot, charts, bar chart, component bar chart, broken bar chart, stem and leaf diagram, or GIVE, which is called as cumulative frequency polygon, tables, figures, pie charts. These all are graphical presentation of data. But to use them is in your research is according to the your categorical variables or your continuous variables. It's according to them. Each frequency polygon or stem and leaf or frequency distribution, they can be used according to the nature of your variables. Then coming to the numeric description. Numeric description is either by measures of central tendency or by measures of dispersion. This is a diagram of histogram, which is used for continuous data. Frequency polygon is shown here again for continuous data. Then numeric descriptive statistics. Numeric, as I said, that it's a measure of central tendency and it's measure of variability. Measure of central tendency, we calculate by mean, which is the arithmetic mean, median, and mode. So mean is actually sum of all the values in a sample divided by the number of values. And just give me a moment. Mean is sum of all the values in a sample divided by the number of values. Sum of all the values in a sample divided by the number of values. That is mean. Sample mean is denoted by small x with a bar. And the sign in the numerator, that sign that you are seeing is the summation sign with the observation. Small x without bar is the observation, number of observations that you have made. And this is the summation sign. Summation means that total of all the observations that you have made divided by n, which is the number of the observations, the number of observations. N is like here in this case, n is 18 participants, and summation of observations, summation x would have is what? Total number of comments that you made in the chat box. Suppose you are 18 participants, that goes into the n in the denominator, and the total number of comments that you have made in the chat box total up till now, say it's 25. So 25 divided by 18 or whatever number is there, that will be the sample mean. Small x with a bar is sample mean, whereas the population mean is denoted by mu, which is again summation of all observations divided by capital N. Capital N is total number of the population. Small n is the total number of the sample, and capital N is the total number of the whole population. So most of the time, rather majority of the time, we take sample from a whole of population and we calculate the sample mean. Most commonly, it is used for interval scores, and it is best applied when normally distributed continuous data is there. Now here, what a big mistake is done by many, that mean is being calculated for the categorical data just because the difference of the coding number which is given to the categorical data is not understood clearly by the researcher. The coding number 1, 2, 3, or whatever number is given to a categorical data does not make it a continuous data. It's at the back, it is still categorical data, but the continuous data where like age, like weight, height, these are continuous data. That is eligible for calculating mean, but categorical data के लिए mean calculate करना गलत होता है, जबकि बहुत सारी studies में ये mistake हुई भी होती है कि उसमें categorical data के लिए mean calculate कर दिया जाता है, जबकि वो applicable वहाँ पे नहीं होगा. मुनी भी आगे मूव नहीं करी फिर. Okay. Median. Median is the observation that divides the distribution into equal parts, and it is used for ordinal scores. Middle value is taken as median, which divides the data into two equal halves. Now, if it is odd number data, then it will be the exact middle value. If it is even number data, then it will be the average of the two middle values will be taken as the median. Most of the time, median is reported alongside mean also. But mean is the most common thing which is calculated for every continuous data. Then mode. Mode is the value that occurs most commonly in the data set, and it is used for nominal scores. It can be unimodal or it can be bimodal in the data, if data is such. So mean, median, and mode. These are the three measures of central tendency. Now let's see here. We are actually doing all this to see what kind of distribution we have got, what kind of distribution the data is following. Is it following a normal distribution graph, or is it following a skewed distribution graph? Normal distribution graph on the right of this picture, you can see that it's a bell-shaped curve, also called as Gaussian curve, and the zero in the center is the point where in normal distribution, mean, median, mode, all three of them, they lie here at one point. In a normal distribution curve, mean, median, and mode, they lie in the very center of the graph. Area under the bell is equal to 1. The center point, which is the mean, area between -1 + 1 shows the standard deviations. Area between -1 and +1 standard deviation, the area covered or the amount of data here is 68%. Area covered between -2 and +2 standard deviation is 95%, and between -3 and +3 standard deviation is 99.7%. Meaning by 68% of the data lies between -1 and +1, 95% of data lies between minus and plus 2 standard deviation, and 99.7% of data lies between minus and plus 3 standard deviation. Area between minus 2 and plus 2 standard deviation is called as area of acceptance. Whatever observation and falls here, which is the 95% of the observation, they fall in this area, they are acceptable because they are all around the mean, which is at the point 0. When the observations are all around, equally distributed, all around this mean between minus and plus 2 standard deviation, they are all acceptable. This is the area of acceptance. Whereas beyond minus 3 and plus 3 standard deviation is the area of rejection, which is 5% equally divided between two tails, 2.5 and 2.5%. 2.5% on the plus 3 onward standard deviation side, and 2.5% onward from minus 3 standard deviation. That is the area of rejection in the tails. These are the two tails, beyond minus 3 standard deviation and beyond plus 3 standard deviation. These are the two tails which are labeled as the area of rejection. Whatever falls between minus and plus 2 standard deviation, that is the area of acceptance. This is the normal distribution curve. Now coming to the skewed distribution, it is either negatively skewed when the tail is on the going towards the left side. When it is negatively skewed, the mean is smaller than the median. If it is positively skewed when the tail is going towards the right side, the mean is higher than the median, meaning by there is large number of values, higher values in the positively skewed diagram, whereas there is lesser number of higher values in the negatively skewed distribution. Mode is still the higher top point, the value which is occurring most of the time, that is mode in both the cases. It's at the higher point. But in the positively skewed diagram, mean is bigger than median, whereas in the negatively skewed distribution, mean is smaller than the median. We are more interested to have a normal distribution curve of the data. So that is why the data distribution is important. Now, what are the measures of variability, dispersion? Measures of dispersion, the first is range. Range is just difference between the highest value and the lowest value. Then we have interquartile range. Interquartile range, when the data is plotted upon the percentile chart, it's between the highest, any higher percentile and the lowest percentile. Lowest percentile is 25th percentile, the highest one is the 90th percentile. So difference between higher percentile, Q3 75th percentile is Q3. So between Q3 and Q1. And this interquartile range is best shown by box and whisker plot. This is the box and whisker plot. Box in the center, and on both sides, the whiskers are shown. The maximum value on the top, 75th percentile, and median is the line drawn in the center horizontally, which shows the equal half of the data. So box and whisker plot is the best way to show your percentile variability. Then the third is variance and standard deviation. Variance is, आप formula नीचे देखिए, under root, the first formula. Variance is actually the average of squared deviations of the observations from the mean, which is xi, meaning by the observation, minus the mean and whole square. Observation which has been done minus the mean of the whole square. When this has to be converted into standard deviation, square root of this variance is taken and it is converted into standard deviation. Small s shows standard deviation of sample. under the square root, summation, the variance, and divided by n minus 1. This gives you the standard deviation. When we are measuring the variability of data, mostly we prefer the standard deviation because it is easier to compute, and it gives you a good spread of out how the data is spreaded out, and it's very sensitive to the skewness. So standard deviation is much preferred for measuring the variability of the data. आपने researches में देखा होगा articles में mean के साथ हमेशा standard deviation दिया हुआ होता है. Mean is given and then plus minus standard deviation is given. Either SD capital is written there or plus minus sign is given. Plus minus actually is showing the this standard deviation between -1 or +1, -2 or +2. So standard deviation is given like this. Whenever conventionally, we take 95% of standard deviation, the data between -2 and +2 standard deviation. But when the research is of very high significance, as per the problem which is being investigated, it's very costly. It has great impact for human population. In that case, the confidence interval can be increased from 95% to 99%. And we are left with only 1% of margin of error, whereas in case of 95%, we have got 5% margin of error going on there. But when the research is of very high value, then we can increase the criteria of measurement, and we can become more stringent and more highly high-tech sort of investigation is then done, and we have got very less margin to do any error in that. So standard deviation is always given along with the mean in the articles. So we have got mean, median, and mode for central measure of central tendency, and we have got range, interquartile range, variance, and standard deviation as measure of dispersion or variability, among which standard deviation is the most preferred one. Now coming to sampling, we have to collect data, and we have to collect data through some sampling method. What is sampling? Sample is part of a whole, and the process of sampling is actually the process of selecting units from a specific population to collect information or data on some variable of interest. Population as a whole, it becomes very difficult for us to manage data collection from a whole population. If you have to do some research in Lahore, it would be very difficult for you to get data from the target population, which is spread all over Lahore. So we take sample. We take sample from that whole target population. We then draw inference from the sample statistics, and we generalize it upon the whole population. This is the concept behind taking sample. Now, why do we take sample? What is the reason that we take sample? We take sample because sample is easier to manage. It is easier to collect data from the sample. It is easier to analyze that data and interpret, and inferences drawn from it. It's time saving, it's cost effective. These are the advantages of sample. And the other main thing is that it's highly impossible for us to take data from the whole population, which is our target population. That is why we take sample. Now, for sampling, it is important to have sample frame. Sample frame is actually a complete list of all the sampling units in the target population from which sample is to be drawn. Target population is the population who is going to get the benefit of your research result from the sample. आपने सैंपल उठाया एक टारगेट पॉपुलेशन से, उस सैंपल से आपने डाटा कलेक्ट किया, उसको एनालाइज किया, रिजल्ट आपने लिया, उसको इंटरप्रेट किया और उसको अप्लाई किया अकॉर्डिंगली। उस रिजल्ट के अकॉर्डिंगली जो भी आपकी एप्लीकेशन बनती थी फॉर टारगेट पॉपुलेशन वो आपने उस पर अप्लाई की। तो टारगेट पॉपुलेशन की कंप्लीट लिस्ट that is called as sampling frame. उस sampling frame में से आप अपना sample select करेंगे. Comprehensiveness of that sample frame is must. Efficiency of sampling scheme should be there, and the comprehensiveness of the sample frame will enable you to have probability of selection equal for every person in that sample frame. If your sample frame is not complete, then the probability sampling will not be effective. Sampling unit is actually the individual member of the sampling frame. In that, each individual member in that sampling frame is called a sampling unit. For example, a medical college with 5 classes going on, sample frame will be the total number of all the students from first year till final year. Each and every single name of each class is going to be there in the sample frame. Then your sample frame will be called as comprehensive. Once all, suppose 150 students per class, 750 students for 5 classes, all the names of 750 students is there on the sample frame, then this comprehensiveness will enable you to give equal probability of selection to any student in that sample frame. आपने जब सबके नाम उस sample frame में रख लिए, तो हर student की equal probability है कि वो sample में select हो सकता है, ठीक है? लेकिन अगर आप sample frame में से ही कोई नाम मिस कर जाएंगे, तो फिर वहां पे bias आ जाए. Why to choose sample? I've already told you that it's cost effective, time saving, feasible. Sample frame is available. Analysis easier to do. Representativeness can be maintained. That is the most important point. And then results can be generalized. Now, what are the sampling types? आपने sample frame तो बना लिया अपना. How are you going to, what kind of sampling you are going to do? We have got 2 main sampling types. One is probability sampling, the other is non-probability sampling. Probability sampling is mainly applied upon quantitative studies, and non-probability sampling is applied mainly for the qualitative study, but in certain cases, it can be applied. It is applied in probability sample, in quantitative studies too. But probability sampling is given more weightage as compared to non-probability sampling, and research becomes very highly creditable by probability sampling, because if probability sampling is done thoroughly and scientifically, then representativeness of the sample is ensured and results can be generalized to the target population. In case of non-probability sampling, inference cannot be drawn and generalization cannot be drawn. So probability sampling is a method by which all the units in the sample frame have equal chance of being selected in the sample, as I already gave you the example of medical students. Non-probability sampling is when all the units of sample frame, they do not have equal chance of being selected in the sample. यहाँ पे कुछ और चीजें अपना रोल प्ले कर रही होती हैं जिसकी वजह से उनका हर यूनिट का इक्वल चांस नहीं होता इन केस ऑफ नॉन प्रोबेबिलिटी सैम्पलिंग. वो हम अभी आगे चलते हैं, मैं आपको उसमें बताती हूँ. Probability sampling is again of 5 types. Simple random sampling, stratified random sampling, systematic random, cluster, and multi-stage sampling. What is simple random sampling? Simple random sampling is simply lottery method. 750 students in one medical college, all 5 classes. आपने उनके नाम पर्चियों पे लिखे और पर्ची बंद की और उसको अपने बॉक्स में डाल दिया, and then whatever sample size you have calculated, you pick up that number of chits from your box, and that is simple random sampling. Without any bias, you don't know what chit you are picking, what name you are picking out of it. So simple lottery method is simple random sampling, or the other way is to do is random number tables on computer. This can also be used for this purpose. Second is systematic random sampling. Systematic random sampling may, what we do is that the sample size is calculated, sample frame is there, but now what we have to do is that we have to take the sample randomly, but in a systematic manner. In a systematic manner. What is the systematic manner here? That we have to calculate a skip interval, and by that skip interval, we have to calculate, we have to take our sample. Interval is shown, I is equal to capital N divided by small n. Capital N is the total number of population here, and small n is the sample size that you have calculated. Suppose the total number of sampling unit is 1000 and your required sample size is 50. So it will be 1000 divided by 50, 20. Every 20th number from the sampling frame will be your study subject. वही 750 स्टूडेंट्स का सैंपल फ्रेम है मेडिकल स्टूडेंट्स का. आपने सिस्टमैटिक रैंडम सैम्पलिंग करनी है उसमें. तो आपकी सिस्टमैटिक रैंडम सैम्पलिंग कैसे होगी? टोटल नंबर ऑफ स्टूडेंट्स यहाँ पे 1000 है, आपके पास 750 है, आपका भी रिक्वायर्ड सैंपल साइज 50 है. 750 divided by 50, what will be the skip interval? Give in the chat box, what is the skip interval here? क्या है जी मुनीब, क्या skip interval आ रहा है?
Sorry, ma'am, I was away from the screen. Can you ask your question again?
मैंने systematic random sampling describe की, and I've asked them that if you have sampling units, total number of sampling units 750 of a medical college, medical students, all 5 classes, and your sample size is 50, what will be the skip interval?
Okay, ma'am.
750 divided by 50 will be
20.
20.
Let me calculate, ma'am. $15.
So every 15th student, you will take every 15th student till your sample size of 50 is complete. But the first student between 1 and 15 will be taken randomly. The first student between 1 and 15 will be taken randomly, and from there onwards, every 15th student will be your study subject. Here in this example shown in the slide, your skip interval is calculated 20. So the first number, the first study subject will be taken randomly between 1 and 20. और उसके बाद जो वो नंबर पिक होगा, उसके बाद आपका हर 20th will be your sampling sample study subject. Is it clear? This is systematic random sampling. Then this is the exercise जो मैंने आपसे अभी करवा भी ली. Systematic sample of 200 students from a list of 10,000 university students. वही होगा 10,000 divided by 200, and your answer is your skip interval is 50. First student will be selected randomly between first and 50, and then from there onwards, every 50th student will be your study subject till your sample size of 50 is complete. This is how you calculate this, how you do the systematic random sampling. Then third is stratified sampling. Stratified sampling is when you make strata. You make strata of population on the base of some common characteristics. For example, strata of two different genders, male and female, strata according to the age groups, strata according to the religion, strata according to ethnicity, strata according to economic status. So you divide the population into different strata according to some common characteristics. After that, again, you do the systematic random sampling in each strata and you pick your random sample. This ensures maximum representativeness of the groups which are there in your study. Giving you an example of this, select a stratified sample of 1,000 people from a population of 100,000 comprising of following ethnic groups: Punjabi, 50%, Pakhtun, 30%, Sindhi, 20%. And this is the number of, in brackets, the total number of population is given. आपने उसका skip interval calculate किया. Every 50% would mean 45,000 का 500 हो गया. 30% of 30,000 is 300. 20% of 20,000 is 200. And you calculated the skip interval. And every 100, because your sample is of 1,000, total is 100,000 divided by 1,000, and you have got 100 person. So every 100 person from each population group will be taken as your study subject, but the first person will be selected randomly between 1 to 100. The number 1 to 100, उसके दरमियान आपका पहला स्टडी सब्जेक्ट जो है वो रैंडमली पिक करेंगे आप, और उसके बाद एवरी 100, जब तक कि आपका 500 ऑफ पंजाबी कंप्लीट हो जाता है, आपका जब तक आपका 300 ऑफ पख्तून कंप्लीट नहीं हो जाता और 200 ऑफ सिंधी कंप्लीट नहीं हो जाता, तो आपका ये इसी तरह 100 every 100 person in your each 3 strata will be taken up for study subject. This is how we do stratified random sampling. Then cluster sampling. Cluster sampling is applied upon large geographical area. When you have to collect data from a population which is spread over a target population which is spread over a large geographical area, then you do cluster sampling, because then that makes it easier to pick up the data. You can select villages, housing units, apartment buildings, colleges, universities, mohallas as your clusters. You complete the sampling list of individuals. Complete sampling list of individuals might not be available, but in some cases you can have it. For example, if you are taking universities or colleges, then you can have, with some hard work, you can have the sampling list. But in case of villages and mohallas, you might not have a complete sampling list of the individuals. And after, once you have taken your clusters, again, your random selection will be there in that too. For example, you are doing a study upon medical colleges, and suppose you are doing a study upon medical colleges. You take throughout the Lahore, you take 6 or 8 medical colleges, cluster of 6 or 8 medical colleges. One medical college is taken as one cluster attached to any specific university in Lahore. Each class in one college is taken as mini cluster, and then all elements of that mini cluster of that one class, all elements, meaning all students, they are included in your sample frame. And from that sample frame, then you will take your sample randomly. This is how we go in cluster sampling. When you have to do data collection from a target population which is spread over a large geographical area, you take clusters. And in the bigger cluster, you can have smaller cluster. And in the smaller cluster, then all elements of that cluster, they are entered into the sample frame. And from that sample frame, then you take your sample randomly. This is cluster sampling. Then we have Multi-stage sampling. Multi-stage sampling, it involves selecting a sample in at least 2 or 3 stages. And the last stage is where your actual study subjects are there. They are calculated in a formula of proportion. In the first stage, larger groups or clusters are selected. In the second stage, population units are chosen. And in the third stage, proportion of the sample unit is calculated. Multi-stage sampling, for example, I can give you an example that if we are studying behavioral problems in primary school children. So to do probability sampling through multi-stage sampling, the first stage would be selection of towns. Suppose we are doing this study in Lahore, in all towns of Lahore. In the first stage, we have to do random selection of towns from the list of towns in Lahore. Then in the second stage, we are going to make a list of all the schools, primary schools in Lahore, and select our schools from there. And then in the third stage, we have to make a sample frame according to the attendance list. And then we calculate the proportion formula and we pick up our sample from the sampling frame. This is multi-stage sampling. Now, the formula of proportion in multi-stage sampling, this is for another session. This cannot be covered, otherwise I'll be short of time and it will become a bit difficult to cover up. So if any one of you who wants to do this formula, we can do it any other time, or you can get in touch with me and I can explain it to you afterwards. So these were the 5 types of probability sampling. Probability sampling, when it is applied scientifically, thoroughly, meticulously, it ensures representativeness of the sample and results can be generalized. Then we come to the non-probability sampling. Non-probability sampling is where all units in the population, they do not have equal chance of being selected in the sample. Why? Because the sampling is being done through means where selection bias is always there. Now, here we have got 4 different types: convenience sampling, purposive sampling, snowball sampling, and quota sampling. Quota sampling is when you allot quota. In a university, 10,000 students are there, 6,000 are male, 4,000 females. We want a quota of 60% male and 40% females. You have got 2 stratas and you take from them. This is as near as good representativeness as in probability sampling, or in case of non-probability sampling. Quota sampling is one type where we can ensure some sort of representativeness here. If we calculate it, if we allot quota according to our need. Again, the procedural steps would be that stratification is done in the population, and from each stratum, then we calculate the quota and we start inviting the cases till our quota is met for that particular stratum. Then convenience sampling is simply on the basis of convenience of the researcher. What is easy to access for the researcher is convenience sampling. Whatever study subject, study group, or workplace where you want to do your research, what is convenient to you, you select it. This is convenience sampling. I want to do a study in tertiary level hospital, and suppose Lahore General Hospital is close by me, I'll take that. This is convenience sampling. आपने कोई ऐसी स्टडी करनी है जो कि किसी भी कॉलेज के ऊपर हो सकती है या किसी भी चीज, और वो आप वो जगह सिलेक्ट कर लेते हैं जो आपके घर के करीब है. So it's easy for you to go there and get data. This is convenience sampling. Convenience of the researcher, easy to access, easy to do, and feasible without any much of hassle in this case. So this is convenience sampling. Then purposive sampling. Purposive sampling is because it serves a specific purpose which is shown in your research question. अगर आपका रिसर्च क्वेश्चन ये शो कर रहा है कि आपने स्टडी करना है लीडरशिप बिहेवियर इन हेल्थ मैनेजर्स, तो आप purposively by a specific purpose you are going to select health managers only and not other staff. This is purposive sampling. Main goal of purposive sampling is to focus on particular characteristics of a population that are of interest, which will best enable you to answer your research question. आप जो रिसर्च क्वेश्चन बना रहे हैं उसमें अगर एक कोई आपने पर्टिकुलर स्पेसिफिक कैरेक्टरिस्टिक को स्टडी करना है किसी खास पॉपुलेशन में, तो फिर आप उस पॉपुलेशन के उसी लेवल पे जाके उन्हीं लोगों को सिलेक्ट करेंगे जो कि उस कैरेक्टरिस्टिक्स को पूरा उतरते हैं उसके ऊपर. दिस इज पर्पोसिव सैम्पलिंग. इसके लिए दूसरे नाम भी हैं, जजमेंटल और सिलेक्टिव और सब्जेक्टिव सैम्पलिंग, लेकिन और द इजीएस्ट वे टू डू say is the purposive sampling. Purposive sampling की आगे से भी कुछ types हैं. How much time do I have, Munib?
We're almost up. Actually, we've taken 20 minutes more than.
Then I'm not going into the detail of purposive. This
Sure,
is the
ma'am.
main purposive sampling. I'm not going to go into the detail of the other variants of purposive sampling. आपके लिए समझना जरूरी है कि purposive sampling क्या होती है. ठीक है. Then the last is snowball sampling. Snowball sampling हम करते हैं whenever we are studying any hard to reach fact, sensitive area, social issue, ऐसा issue के जिसके ऊपर data लेना या the study subject is not open upon it, such sensitive topics they are researched through snowball sampling. What happens here is like a snowball, जैसे snowball start होता है just from a small particle and it keeps rolling down and it keeps on getting bigger and bigger and bigger. So the first study subject, there is hard work involved in it to identify and to locate him. Once you access to him, you get his trust, he starts opening up to you, and then he will give indication to you of the second person, of the third person, or any other person. For example, in HIV/AIDS, for example, in drug use, for example, substance use in students. These are all very sensitive issues. For example, psychological problem in students. People are not open about it. So the first student would be difficult to access, but once you have accessed him, you have taken his trust, then you can find, he will indicate you towards the other students too. So this is snowball sampling. Non-probability sampling, अगर हम clump कर लें सारे merits को, so it's easy to carry out, it's cost and time effective. It gives you quite a lot of enriched data because you are doing close contact with patients or the study subjects. Then again, you can make logical generalization, not the inference, but logical generalization, what patterns and trends you have seen in the study subject. You can explain them that logically the same patterns can be seen in the target population. But the major demerits are that representativeness of the sample is not there, and generalization cannot be done. There is a lot of researcher bias present in it, and there is selective bias present in it, and underrepresentation or overrepresentation of the sample can be there. So these are the demerits. I had kept this an exercise, some scenarios for you, but I'll give it to you afterwards and you can apply it and see what study design or what type of sampling can be done here. We'll move on to hypothesis testing. हमने कहा कि descriptive statistics generates hypothesis, and hypothesis after generation needs to be tested, whether it is going to be accepted, it is right or not, or it is rejected. Now, tools of classical statistical inference, they are, what does they mean? That principal objective of researcher is to do comparison. And statistical inference is to reach some conclusion from the sample data and to support our conclusion with probability statement. Tools for this are estimation or hypothesis testing. I'm not going to do estimation here. We are going to do hypothesis testing here. Now, in hypothesis testing, definition is that hypothesis is a statement of belief used in the evaluation of population values. It's a statement of belief. There are two types of hypothesis. One is null hypothesis, which is statement of no difference or no relation. It is denoted by H naught. Statement of no difference or no relation. There is no difference in, आप पिछली एग्जाम्पल को याद रखिएगा, हम उसी को लेके चल रहे हैं आगे. There is no difference in degree of obesity in teenagers with regards to unhealthy eating habits. No difference. It's statement of no difference or no relation. Whereas alternate hypothesis states that it is a statement of difference or there is association. This is actually the research hypothesis, what the researcher is expecting to find in the results. And the statement here will be, there is difference in the degree of obesity in teenagers with regards to unhealthy eating habits. Null hypothesis says there is no difference. Alternate hypothesis says there is a difference. If null hypothesis is accepted, that means the alternate hypothesis is rejected. If null hypothesis is rejected, that means the alternate or the research hypothesis is accepted, which means that there is a difference in the degree of obesity in teenagers with regards to unhealthy eating habits. Now, in testing a hypothesis, we need some kind of test statistics. Test statistic is used to determine the relative position of the mean in the hypothesized probability distribution. ये वही normal distribution है, and test statistic जो हम apply करते हैं, जो test हम लगाते हैं, वो test statistic जो calculate होता है, वो हमें actually जो हमारी hypothesized distribution है, उसका mean हमें बता रहा होता है. Critical region is the shaded area in the tails is the other region is the critical region. It actually tells you the probability that a test statistic falls in the critical region is denoted by alpha. आप इस diagram को देखें, इस curve को देखें, alpha is denoted in the at the start of the shaded area. This is the critical area in one tail and in the other tail. 2.5% in one tail and 2.5% in the other tail, and the rest of the area is the area of acceptance, which is 95% between plus minus 2 standard deviation. The critical region is probability of a test statistic that it can fall in the critical area, and then it will be the area of rejection. It is denoted by alpha. Now, critical value is given to this calculated test statistic, and that critical value is given in a table form. The critical values, they are given for the test. Either t-test or z-test is applied, and whatever test statistic is calculated, the critical value for that test statistic is taken from the table of critical values for t and z-test. ये हमारी अपनी मर्जी की नहीं होती हैं, ये standardized universal values हैं which are given for t-test and for z-test. Whatever value test statistic is calculated in our data set, उसके against आपकी critical value जो है वो आप उस table में से देखें. और ये जो critical value है, it is taken as the significance level which is denoted by alpha. Alpha is given by p-value, and p-value less than 0.05 is taken as statistically significant at conventionally at 95% confidence interval and 5% margin of error. So these are the components when we are testing a hypothesis. We have to apply a test statistic. We have to identify the critical region. We have to identify the critical value which is against that test statistic which we have calculated. and that critical value is a given value in the table of values for t-test and z-test, and the level of significance alpha is denoted by given by p-value, which is taken less than 0.05 is taken statistically significant. Conventionally, all our studies are at a significant level where less than 0.05 p-value is taken significant and confidence interval of 95%. Very rare we take a 99% confidence interval where all our criteria become very, very stringent depending upon the nature of the research. Now, the non-rejection area is the acceptance area. The area between plus minus 2 standard deviation, 95% area. This is the non-rejection area, and the values or the observations which are falling here around the mean, all around the mean, they are acceptable. So the non-rejection area is denoted by 1 minus alpha, where 95% of the time observation they fall, which is not unexpected. It is expected, actually. It is expected that 95% of the time, all these observations, they are falling there. Test of significance is applied, or the hypothesis test is applied. And this is actually, now we are establishing the validity of a claim by determining whether the test statistic falls in the critical region or not. That is why we apply a test of significance. Whatever test of significance we have applied, according to the result, according to the critical value which has been calculated, the test statistic which has been calculated, and the critical value against it, in response to that, either the null hypothesis will be rejected and alternate hypothesis will be accepted, or the null hypothesis will be accepted and the alternate hypothesis will be rejected. This is how you will interpret your results. Now, you must have seen results written as one tail or two tail. What does this mean? This is actually the test direction. The test direction would be that your alternate hypothesis is giving you the direction. अगर हम ये कहते कि हमने कहा alternate hypothesis में there is difference in the degree of obesity in teenagers with regards to unhealthy eating habits. It can be both ways. अगर unhealthy eating habits नहीं हैं या हैं, तो obesity हो भी सकती है और obesity नहीं भी होगी, or any other hypothesis for that matter, which is not giving you actually that it is going towards the higher side or the lower side. It's open. Whatever will be the test statistics will be calculated, will actually give you the direction of your hypothesis. That is why the test statistics is always it should be two directional. It should never be one directional. It should never be giving the direction towards the higher side or the lower side. Alternate hypothesis, if it is giving you direction, one direction, then actually it limits the scope of that alternate hypothesis. So always it should be two directional, which is always preferred. Now there are two types of test of significance. One is parametric test and one is non-parametric test. For parametric test to apply, there are some underlying assumptions which should be fulfilled. One is that data should be normally distributed. Second is that homogeneity of the variances should be fulfilled. That is, variance within each population should be equal for all the population. आपकी टोटल पॉपुलेशन के अंदर से जो आपने हर पॉपुलेशन का छोटा छोटा ग्रुप रखा हुआ है, उसकी जो वेरिएंस है वो आपकी पूरी पॉपुलेशन की वेरिएंस के बराबर होनी चाहिए. एंड लीनियरिटी, आपकी जो वेरिएंस और आपका डाटा की नॉर्मेलिटी है, और ये तमाम चीज एक लीनियरिटी में इसकी रिलेशनशिप जो है वो चलनी चाहिए. जबकि नॉन पैरामीट्रिक टेस्ट जो है वो उस वक्त लगाए जाते हैं कि जब आपका डाटा सेट नॉर्मली डिस्ट्रीब्यूटेड नहीं है। जब नॉर्मली डिस्ट्रीब्यूटेड नहीं होगा, नॉन नॉर्मल होगा, तो इसका मतलब है कि आइदर वो लेफ्ट स्क्यूड होगा या वो राइट स्क्यूड होगा। मतलब ये या तो वो पॉजिटिवली स्क्यूड होगा या नेगेटिवली स्क्यूड होगा। उस सूरत में आप नॉन पैरामीट्रिक टेस्ट लगाएंगे। डाटा की नॉर्मेलिटी को चेक करने के लिए जब आप डाटा अपना ऑर्गेनाइज करके उसको क्लीनिंग कर लेते हैं, तो सबसे पहला एनालिसिस का स्टेप आपका यही होता है कि आपने डाटा की नॉर्मेलिटी, टेस्ट अवेलेबल होते हैं एसपीएसएस में, आपने वो लगा के डाटा की नॉर्मेलिटी चेक करनी है। जैसे ही आपके सामने क्लिक करेंगे, आपके सामने ग्राफ्स और फिगर आ जाएगा। आप अगर डाटा नॉर्मल है, देन यू विल गो फॉर पैरामीट्रिक टेस्ट। These are the two parametric and the non-parametric tests. List of two parametric and non-parametric tests available होते हैं आपके सैंपल के मुताबिक। वन सैंपल है, टू इंडिपेंडेंट सैंपल्स हैं, टू डिपेंडेंट सैंपल्स हैं, आपने कोरिलेशन या मल्टी ग्रुप्स रखे हुए हैं, उसके अकॉर्डिंगली आपकी नॉर्मेलिटी या नॉन नॉर्मेलिटी ऑफ द डाटा के ऊपर डिपेंड करेगा कि आप इनमें से कौन सा पैरामीट्रिक या नॉन पैरामीट्रिक टेस्ट जो है वो चूज कर सकते हैं और वो उसको अप्लाई कर सकते हैं। अप्लाई करना कोई इतना मुश्किल नहीं होता, सिर्फ आपको ये वाला कॉन्सेप्ट जो है ये क्लियर होना चाहिए। आपने सिर्फ एसपीएसएस में एनालिसिस में क्लिक करना होता है और आपके सारे रिजल्ट्स इन अ सेकंड सामने आ जाते हैं। ठीक है। सो सिस्टम ऑफ स्टेटिस्टिकल एनालिसिस हमारा एक जनरल प्लान कैसे आप बनाएंगे, that you have to state your research hypothesis, you have to state the level of significance, p-value, you have to give calculate the test statistics, and then you have to compare the calculated value with the given critical value and see whether your result falls, your decision falls in the acceptance region or in the rejection region. Wherever it falls, you have to then give your statement of result and interpret it. This is how you plan your own research analysis. And how would we select between parametric and non-parametric test? I've already told you, it depends upon your research question or the hypothesis that you have developed, then the normality or the non-normality of your data set and underlying assumptions, and your need for inference and generalization of results would make the base for you to select between parametric and non-parametric tests. And thank you. I love your patient listening. Thank you very much. I had to wind it off quickly, but the things, some of the things they need a little more of time, which sometimes some other time can be done. I hope it has been beneficial for you. Love your patient hearing. Thank you.
Thank you, ma'am. It was a wonderful lecture, and I'm sure all the participants have learned a lot from you. So I thank you on behalf of all of them. And if you allow, to I may share your email address with them so that if they have any queries, so they may direct them to you. Is that okay?
Sure.
Okay, but I'll be taking the feedback and I'll be communicating it to you. If you have anything you want to share with the participants later on, you can always send it to me and I can forward it to them. Okay, ma'am. Thank you again for this wonderful lecture. Allah Hafiz.